Hi, it's me again. Today we're going to be talking about special right triangles. We're going to do that for 2 days because there's two different kinds of special right triangles. Today we're going to be tackling the first one. So our first special right triangle actually comes from a square. So we just finished our chapter on quadrilaterals. A square is a quadrilateral. What do you remember about squares? Well, hopefully you remember that they have four congruent sides. They have four right angles because our definition was that it was a regular quadrilateral. So if we take just one of our diagonals and draw it in, I'm going to draw this from the bottom left up to the top right. Do you see that we've actually created two triangles here? So this triangle right here is a right triangle because it has 190-degree angle, same with this one. And if you'll notice, this right triangle, not only does it have a 90-degree angle, but it has two congruent sides, which means it's isosceles. So isosceles right triangles actually come from squares. So that's what we have rocking right here. So in this isosceles right triangle, if you remember anything about isosceles triangles, not even right triangles, but just isosceles triangles, they have two congruent sides and two congruent base angles. So not only are these two sides congruent, those two angles are congruent. Now, because this is isosceles, these two sides are the same length. So 10, 12, 115, 97, no matter how big they are, these are going to be the same length. So I'm going to pick some really small numbers here. I'm just going to make each side 1. All right, so if each one of these sides is 1, how big is the hypotenuse? So if you'd like to take a second and try to figure that out, please feel free to pause the video and get after it. So, right triangle, we know two sides. We just finished yesterday's Pythagorean theorem, right? So we can do 1 squared plus 1 squared equals, we can call it c squared if we want. So that would be 1 plus 1 equals c squared, so that's 2. So if 2 is equal to c squared, and then we square root both sides, then c is equal to the square root of 2. So in this isosceles right triangle, where these two sides here, which are called legs, so that's not a plural leg, that's a leg, and this is a leg. Our hypotenuse will be the square root of 2. Okay, here's the thing. Do you remember talking about similar polygons and similar triangles? I think this was back in semester 1, so it's been a really long time. But all 45, 45, 90 triangles are similar because they have the same three angles. So remember a minute ago when I said this is a 90-degree angle and these two are congruent because it's isosceles? How big is this angle then? It's 45 degrees because we have 90 degrees left for these two angles, but since they're both the same, 90 divided by 2, so each one of those angles is 45 degrees, which means every single isosceles right triangle, no matter how big the sides are, if this is 90 and this is isosceles, this is going to be 45 and this is going to be 45. If this is 90 and these are congruent, this is going to be 45 and this is going to be 45. So we actually call these kinds of triangles 45, 45, 90 triangles. And they are the isosceles, if I can spell that right triangles. So isosceles right triangles, we call those 45, 45, 90 triangles. All right, so back to the similar bit. So if these are all similar, that means the scale factor between the sides has to remain the same. Do you remember that whole scale factor thing? So if this is 1 and this is 3, what's the scale factor? How much bigger is this shape? Well, our scale factor would just be 3 divided by 1, so that would be 3. So our scale factor is 3, and you can see that 1 times 3 is 3. Well, that means the scale factor between these two sides has to be the same. So 1 times 3 would be 3. And the scale factor between these two has to be the same. So 3 times the square root of 2 would just be 3 square root of 2. Now, a lot of you guys probably are more comfortable with the decimal. That's okay. I'll write it here in just a second. I'm actually going to leave it like this because I'm going to have us see a pattern here. If you don't happen to remember the pattern, we're going to look for a pattern. So 3 times the square root of 2. So if you like the decimal, because that's what you're comfortable with, it's about 4.24. These mean the same thing. The squiggle marks here, that's the approximate symbol. Anytime you round, you really should use the two squiggles instead of equals because it's approximately this. It's not exactly that. All right, so let's look at our next one. If this side is 8 and these are congruent, first of all, I don't even have to use scale factor to find that. Wouldn't this also have to be 8? That's what happened over here, right? This was 3, that's congruent, that has to be 3. So really, we just need to use that scale factor idea to find our hypotenuse. So our scale factor would be 8 divided by 1, so that's 8. So 1 times 8 is 8, 1 times 8 is 8, so the square root of 2 times 8 is 8 square root of 2. I'm going to apologize in advance if my dog starts barking. He's staring out the window and there's some commotion out there. All right, so in our next one then, if this side is 10, this would also have to be 10. All right, now you may have already started to see a pattern here, but if not, that's all right. Our scale factor is going to be 10 divided by 1. So that's going to be 10. So 1 times 10 is 10, 1 times 10 is 10. Square root of 2 times 10 would be 10 square root of 2. All right, what do you notice? 3, 3, 3 root 2. 8, 8, 8 root 2. 10, 10, 10 root 2. Square root of 3. Square root of 3. Ugh, what happens here? So let's look at the scale factor. So we've got square root of 3 divided by 1, square root of 3 divided by 1. So that's just the square root of 3. So we're going to have to do the square root of 2 times the square root of 3. Square root of 2 times the square root of 3. Now the same thing we did here, right? We did the square root of 2 times 10. We did the square root of 2 times 8. We did the square root of 2 times 3. So here we're just doing the square root of 2 times the square root of 3. Well, since both of these are under square roots, this actually equals 2 times 3, that's 6. It's the square root of 6. So we can actually use similar triangles to help us find missing sides of a special right triangle if we only know one side. So why is that a big revelation? Well, yesterday we were finding missing sides of right triangles too, right? So why is this such a big deal? Well, yesterday we had to know 2 sides. Today, weren't we only given one side and then we just used some logical thinking to find the other 2 sides? So this is such a big deal because if it's a 45, 45, 90 triangle, we only need to know one side. Maybe it's a leg, maybe it's the hypotenuse, but as long as we know one of them, we'll be good to go. So our 45, 45, 90 triangle is a special right triangle that follows a very specific pattern. So if we go back up here, look one more time, we have 1, 1, and this technically is 1 square root of 2, 3, 3, 3 square root of 2, 8, 8, 8 square root of 2, 10, 10, 10 square root of 2, square root of 3, square root of 3. Technically, this is square root of 3 square root of 2. We just multiply those together, right? So what's the pattern? Well, no matter what this side is, right? Let's call it a leg. Leg, this is still a leg, right? And they're congruent, so this would also have to be a leg. So this is a leg, this is a leg. What would we call this? This would be leg times the square root of 2. Now, if you don't like to do all that writing, you can also use x's in the place of the word leg. So your teacher might have done that. Maybe this is x, so this would be x, and this would be x square root of 2. So you have a couple options when you think about it. This is a little busy. I'm going to actually move this to the other picture. So sometimes your isosceles right triangle will be marked with 2 congruent sides. Sometimes your isosceles right triangle will be marked with 2 congruent angles. But if your angles are congruent, your legs are congruent. So what I was saying over here, instead of calling this a leg, we could call that x. We can call this x. So this would be whatever your leg is, x times the square root of 2. So we can use scale factors, or we can use this pattern to actually help us anytime. So let's think about this pattern for a minute. If we know this side is x, then isn't this side just whatever that is times the square root of 2? So if this is 9, this would be 9 square root of 2. If this was 13, this would be 13, and this would be 13 times the square root of 2. If this were, what if this were 2 root 5 though? Well, this would be 2 root 5. And this would be x, which is 2 root 5 times the square root of 2. Now, just like over here on this problem, anytime you have those square roots, you need to multiply them together. So what would this actually equal? 2 root 10. Is that what you were thinking? So we can use this shortcut to help us. So if we know the leg, then we can just keep it the same, multiply by the square root of 2. Here's where it can get a little bit tricky. What if we know the hypotenuse instead? Okay, so if we knew the leg, we would just multiply it by the square root of 2, but what if we know the hypotenuse? How do we go backward? Well, we have two options. Our first option is our scale factor, right? So let me go back to that original picture. So this was 1, this was 1. We did the Pythagorean theorem and got the square root of 2, right? All right, so if we know the hypotenuse is 8, it matches with the square root of 2 because those are both the hypotenuses. So our scale factor would be 8 over the square root of 2. Okay, so this is where it can be a little confusing, but the square root of 2 times 8 over the square root of 2 actually equals 8. Now, you can believe me, because I'm a math teacher. I know what I'm talking about. Or, let me just show you really quick. If we take the square root of 2 times 8 over the square root of 2, do you guys know that these will cancel out and just leave you 8? So if we do this hypotenuse times the scale factor, it'll equal this. So if we do this guy, leg, times the scale factor, it'll equal this. So according to that, 1 times 8 over root 2, our leg is 8 over root 2. Same thing over here, except we don't even have to do any math. These are congruent, so this would have to be 8 over root 2. So that's method 1, that's the scale factor method. Now, this method might be a little confusing that way, so let's think of it a different way. Let's think of it using the shortcut triangle. I like to call this my shortcut triangle, x, x, x root 2. So when we knew the leg, we multiplied to get the hypotenuse. Do you guys remember the hypotenuse is always the biggest side, and so we multiply because we're trying to get a bigger number? Well, what if we're going the opposite direction? Don't we already have the bigger number? So instead of multiplying by the square root of 2 to get to the smaller number, we would divide by the square root of 2. So if we took the hypotenuse and divided it by the square root of 2, we would get the leg. So let's look at that up here. If we had 10 square root of 2, that's the hypotenuse, and we divided it by the square root of 2, those will cancel. Don't we just get the leg? If we have 8 root 2 and we divide it, because we want the smaller side, by the square root of 2, those will cancel. Don't we just get 8? Same thing here. 3 root 2 divided by root 2 will just give you the leg. So if you know the hypotenuse, you can divide by the square root of 2. Well, what does that look like? We would take 8 divided by the square root of 2, and that would equal the leg, which is exactly what we said it was a minute ago. Now, you may remember some kind of simplifying, and it's called rationalizing the denominator, that your geometry teacher had you do during the school year. I am not worried about that. I just want us to be able to get to this. If you would like to practice rationalizing the denominator, just hit me up with an email, and I can give you some tips or a short video on it if you want to remember how to do it. Otherwise, you can just leave your answer just like this. All right, so I just did a lot of talking here about this, and I had 2 different strategies. You may got a little lost. So let's take a look at this guy right here. I'm going to use the shortcut triangle first for this one. I find the shortcut triangle a little bit easier, but that's my personal preference. It doesn't make it the right way or the best way. It's just my personal preference. So this is the hypotenuse, and I know it's the long side. And I'm going to find the leg, and I know it's a shorter side. So anytime you're going from long to short, you're going to divide. So I look at my triangle and say, what am I going to divide by? Well, I'm going from long to short, so I need to get rid of the square root of 2. So for my leg, it's going to be the hypotenuse divided by the square root of 2. That's it. That's your answer right there. If this one is 10 over root 2, then this guy is 10 over root 2. That's it. Now, it may seem too simple. It's really, that's it. That's all it is, I promise. I'm not trying to confuse you. It is just that simple. All right, so let's do a couple more. So this one I'm asking you to use your shortcuts in the directions, but actually if you like to use similar triangles, please do that. I want you to find what works for you. There is no one right way. There's just some math rules we have to follow. All right, so let me put my picture here so I can x root 2. I'm going to use the shortcuts. So what do I have? I have a leg, and I know it's a leg because it's marked congruent to this other guy. So I have the x side, so that means this is also an x side, so this will be 3 root 2. They're congruent, they're going to have to be the same. So here's where we got to put our thinking cap on. From x to x root 2, we're getting bigger, so we're going to multiply. So anytime you're getting bigger, you're going to multiply. And what are you going to multiply by? The square root of 2. So this is going to be 3 root 2, because that's already the leg, times another square root of 2. What happens? Well, the 2's are both under square roots, so we can multiply them. So that'll be 3 times, now the square root will stay, so 3 times the square root of 4. If you get here, you're doing awesome. What's the square root of 4 though? Just 2, so 3 times 2. So our hypotenuse would equal 6. So A will equal 3 square root of 2, and C will equal 6. Okay, let's look at B. So in B, we know the hypotenuse. Okay, so that's our hypotenuse. That's the longest side. So anytime you know the long side and you're trying to find the short side, you're going to divide. Getting bigger, multiply. Getting smaller, dividing. Just like you would think. Like when you multiply something, the number gets bigger. When you divide something, your number gets smaller. So we're dividing this time. So what are we going to divide by, though? Well, the only number that's here that we can divide by, right? X root 2 to x. We want to get rid of the square root of 2. So we're going to do 12 root 6. We're going to divide it by the square root of 2. If this makes sense to you, you're doing awesome. There is one more thing we can do, though. So remember over here, because these were both under the square root, we could multiply them. Since these are both under a square root, we can divide them. So what's 6 divided by 2? It's just 3. So this is 12 times the square root of 3. Now notice the square root doesn't go anywhere. The square root stays because the square root is this whole thing. Both of those are being square rooted. So this is 12 root 3. Oh shoot, is this an isosceles right triangle? Just making sure you're paying attention. These are congruent, so the sides are congruent. It's an isosceles right triangle, which means not only is B equal to 12 root 3, but A is congruent to it, so it's 12 root 3. All right, challenge yourself. Pause the video and see if you can figure out letter C. So for C, we have the hypotenuse, and we're going to a leg. So we're getting shorter, so we're going to divide. What are we going to divide by? The only number that's in our triangle is the square root of 2, so we're going to divide by the square root of 2. So we've got 4 root 10, we're going to divide it by the square root of 2. Now these two are both under a square root, so they can be divided. The 4 is not under a square root, so you can't divide it with the 2. So the 4 will stay, and 10 divided by 2 is just 5, so we keep the square root, so 4 root 5. So that's how big this side is, but because this is a 45, 45, 90 triangle, it's isosceles, that's also how big that is. So A is equal to 4 root 5, and B is equal to 4 root 5. All right, next, gotta put boxes around all my answers. Same thing. Take a look at this problem, pause the video, challenge yourself, see if you can get it. So this time, 5 root 8 is a leg, so we are going to, the hypotenuse, it's getting bigger, so we're going to multiply. Now B is just congruent, because they're already marked congruent, so B we know is 5 root 8, so we need to figure out C. So we're going to take 5 root 8 and we're going to multiply it because it's x times the square root of 2. We're going to multiply it by the square root of 2. So that'll give me, these are both under a square root, so 5 times the square root of 16. If you got here, you're doing awesome. Square root of 16 is 4, so this is really 5 times 4, so C is equal to 20. How'd you do? Figure it out? Does it at least make sense once it's explained? That's the important part. Guys, anytime you have notes or you're confused, jot your question down like on your note sheet, and you can just take a picture of it and send it to me, and I can answer your question by looking at your picture. But if you have any questions at all, hit me up. That's what I'm here for. That's why I get paid the big bucks. All right, last problem here. Draw and label a figure to model each problem. There's only one. Then use your new shortcuts to solve the problem. So we're going to find the length of the diagonal of a square. Okay, so first of all, we have a square. Oh, that was a pretty good square. So all of our sides are congruent. All of our angles are right angles. All right, so find the length of the diagonal. So I need a diagonal. If the perimeter is 124 inches long. So what does perimeter mean? That's all four sides, right? And if all four sides are congruent, we need to cut this guy into 4 equal pieces. So each side is 31. Now, if these shortcuts have not been making sense to you, good news is you can always use the Pythagorean theorem. 2 of your sides are congruent, so we can just do 31 squared plus 31 squared equals c squared and solve that problem. Not a big deal. If you like that method, use that method. If you like the similar triangle method, use that. Our scale factor, these are both legs, so 31 divided by 1, because our picture would be 1, 1, and square root of 2, right? So 31 divided by 1. So our scale factor would be 31. So 1 times 31 is 31. 1 times 31 is 31. So the square root of 2 times 31 would be 31 root 2. Or if you like our new shortcuts, use that. You have 3 methods now. So this is x, and x root 2. So we already know this side, which is 31, right? 31. So if we want to go to the bigger side, we're going to multiply. So we're going to multiply by the square root of 2. So this would be 31 root 2. So no matter what you do, you'll get the same answer. So our diagonal is 31 root 2 inches. All right, as always, if you have any questions, jot them down, send me an email, come to Zoom office hours. I am happy to help. Otherwise, have a fantastic day.